Hi, this is Bart from the NoPod project at nopod.org, and today I'm going to teach you a little bit about a basic solar electric or photovoltaic system. Now before we get started, you need to remember if you're dealing with batteries like car batteries that are flooded, these batteries are sealed, but if we were using flooded batteries, we would need to have safety glasses, possibly gloves, and other clothing to protect us in case there was an accident with the acid inside the battery. Also, I'm not going to talk about electrical codes here, but if you do have local electrical codes in your part of the world, make sure you check into what they are and try to follow them. Now, in our system, we're going to keep it as basic as possible here, and we'll talk about other types of solar systems in other videos. But for today, we're going to be dealing with a 12-volt nominal system. That's direct current, just like your car uses. And for this system, we have three components. We have our solar panel or photovoltaic module, and this is what creates the electricity from the sun. We have batteries, that's where our electricity gets stored until we can use it. And we have a charge controller. And the charge controller basically just turns the solar panel on and off when the batteries get full so that the batteries don't get overcharged. With any solar panel, you basically just have two wires coming out. Solar panels are a little different, but in general you should find a place where there's either a junction box like this on the back, and here we've got our plus wire coming off here and our minus wire coming off here, or sometimes solar panels just have the wire attached from the factory. Either way, you'll end up with a plus and a minus. Now, it's handy to have a voltmeter. And this is a little fancier than you need, but any kind of voltmeter will do. And on your voltmeter, you want to set your voltmeter to the lowest setting. On ours, it's 200 volts. So we're going to set it to 200 volts. And you want to make sure it's set to DC. Ours has an AC-DC button. We're going to push it so that it's set for 200 volts DC. That's our lowest setting. Now the interesting thing about a solar panel is even though this is called 12 volt nominal, we're dealing with slightly different voltages. When our batteries are all the way full, they're going to be around 14 volts, and that's where the charge controller shuts all the way off. When our batteries are half empty, they're going to be about 12 volts. And when they're completely empty, they're going to be at 10.5 volts. So remember, 14 volts full, 12 volts in the middle, and about 10.5 volts is completely empty. And you really usually don't want to run your batteries all the way down. So when they get below about 12 volts, that's a good time to either quit using power from them or make sure you get them charged up. Now, our solar panel puts out about 19 volts open circuit when it's not connected to the batteries. We can put our meter on here and check this out. The reason solar panels do this is in case clouds or they're not completely in the sun, you'll still be making enough electricity to charge your batteries. Here we see with the 12 volt panel, we're putting out 16.6 volts, and I don't have the panel aimed directly into the sun right now. Now, as soon as we hook the panel to the batteries, and for temporary, it's no problem, we can check our batteries too. Right now today, our battery is at 12.9 volts, so it's a little bit over halfway charged. You can even go ahead and just simply hold these wires, and with 12 volts, you really don't have the electrocution danger that you do with high voltage. So we can go ahead. You just want to make sure that you get the plus to the plus and the minus to the minus. Also with batteries, if you touch a piece of metal across there, you'll get what's called a short circuit. And a battery has a lot of energy in it. So if you get a short circuit like that, it can actually melt wrenches, tools, and that's where the real danger comes from, is not from electrocution, but from actually burning yourself or letting a lot of the energy out of the battery suddenly. So we'll slide the battery over a little bit here. And as soon as we put our solar panel on, we can see that it went from 12.9 to 13.1. So what we have here is the solar panels bringing the battery voltage up a little, and the battery is bringing the solar panel voltage down to meet what it is. And so it's going to continue over the, if we left this on here over the next few hours, now it's up to 13.3, we would see it slowly start to rise. Now the thing that you got to make sure of is that we don't leave it on here until the battery gets overcharged, because if it does, we could actually damage the battery, especially sealed batteries like these ones. So we'll take that off for now. And it drops back down to 13 volts, where it was 12.9 before, so you can see that we actually did put a little bit of energy into the battery. Now, with your battery, one battery often isn't enough, so you have to connect the batteries together somehow. So typically you want to use a cable like this to connect your batteries together. And it's important that with low voltage, you use a big enough wire. And the reason is that the lower the voltage, the bigger wire it takes to carry the same amount of electricity. On your solar panel, you're not putting as much electricity into the battery as you can take out of the battery with your load. So that's why you don't have to have as big of a wire on your solar panel. Now, for your solar panel to the battery, I would recommend the smallest wire being about a 12 gauge wire, or if you're in a country that uses metric, about a 3.3 millimeter wire. And distance is also very important at low voltage. So for a solar panel this size, about 20 feet or 13 meters is as long as you want to go with this size of wire. You can go further, but you just need to make sure your wire's a little bit bigger. For a battery cable, since you can pull more electricity out of the batteries quicker, we're using a bigger cable, or a 6 gauge cable, which is about a 13 millimeter wire. There are two ways to hook your batteries up. The first way is what they call parallel. And we're going to do a parallel connection here by connecting our positive to our positive and our negative here to our negative. And I'm just using these little wires as an example because they're easy to hook up. And we can see in doing this that we haven't changed the voltage at all. It's still 13 volts to these batteries. What we have done is doubled our capacity. We've doubled our amp hours, or the amount of energy we can draw out of these batteries. Now sometimes on a 12 volt solar system, it's common to use a 6 volt battery. And in that case, you need to put the batteries in what's called series. And so this seems a little counterintuitive, but what we're going to do is we're going to take our wire from our positive on our battery, and we're going to connect it to our negative of our other battery here. Now it might seem like we're creating a short circuit, but we're not, because it's going from the positive of one battery to the negative of another. And what that leaves us is with an open negative and an open positive. Now if we put our meter on the negative and positive, we're going to have doubled our voltage. Here our voltage is 25.9, but we have the same amount of amp hours. So you would use this if you had 6 volt batteries and you wanted to make a 12 volt system, like golf cart batteries. So that's the difference between series and parallel. Now, you might wonder about how you use the energy from the batteries, and it's really simple. Just the same way we're hooking our meter up, we can take and we'll make our batteries back into two 12 volt batteries by disconnecting these wires, and we can put our meter back on, and we're back to a 13 volt or a 12 volt nominal battery, and we're going to hook our load wires And you can do this with a ring terminal or any kind of terminal. You can even put a wire under this and tighten it down if that's all you've got. But it's a lot better when you're making these connections to use some kind of terminal, and that'll be different depending on where you are in the world. This is the most simple way to attach a load to a battery, is just to hook it directly to it. You can see our LED light comes on and runs. And this light's what we call a load. Now, for most loads, you want to use some sort of a fuse or circuit breaker in between the load and the battery. And what that does is protects the wire from too much electricity flowing through it. With a small load like a light like this, and we can see our short circuit here. Nothing dangerous, but that's what happens when you touch the plus and the minus wire together. We'll disconnect that so we don't have another short circuit. So once again, remember, on your loads, you want to use a fuse or a circuit breaker, if possible, to protect the wires. And just as if in the case that we had a short circuit here, if you have a short circuit in your wires and you don't know about it, if you've got a fuse or a circuit breaker in line, instead of your wires getting hot, melting, possibly starting a fire, that circuit breaker or fuse is just going to trip and blow, and everything will be okay. So it's essentially a way of protecting your wires and yourself from getting too hot. Now, the other place you might want a fuse or a disconnect is in between your solar module and the battery or the charge controller itself. And they call this an array disconnect. Typically, you'll have more than one solar panel or an array of panels. And so it's kind of nice to have a way of shutting off the solar panel, because otherwise, it's always making electricity if it's out in the sun. The only real way to turn off a solar panel is to actually put something over it to cover it from the sun. The other thing that we haven't talked about too much is our charge controller. And charge controllers can be complex. This one's a little bit fancier, or there's some very simple ones. But we'll look inside here. Hooking up the charge controller is real simple. What we have here is 2 terminals for the battery positive and 2 for the negative. And really the positive is the one we're going to be most concerned with. It's going to come from the solar panel. It's going to come in to our charge controller box, and we would hook it to one of these wires right here. Then we would take another piece of wire like this. We could strip it down, and it would go to the other positive terminal here. And then it would go from the charge controller to the battery. And what this does is it allows the charge controller to disconnect the positive wire. And this will only happen as this charge controller is a little fancier. As the battery voltage gets up to the high 13 volts, it's going to start slowly tapering down the charge. And then when it gets to 14 volts, it's going to turn it totally off so that our batteries don't get overcharged. Now, there is one situation where you might want your batteries to get slightly overcharged, and that's after you've been using them for a while. If they're a sealed battery like this, you never want to overcharge it. But a flooded battery, like a lead acid battery, once in a while it's a good thing to overcharge it, and that's called an equalizing charge. And what that does is stirs up the electrolyte inside the battery, and it'll make your batteries last longer, and it'll give you more battery capacity. So maybe once every 3 months or 6 months, if your charge controller's made for it, there's usually a button on it. This one here, you hold down this button on the side, and it'll give you a 1 hour equalized charge, and it'll kind of boil the electrolyte in your batteries. It's good to pay attention while you're doing this, but also you can manually equalize charge battery, and you can just bypass your charge controller, and being careful to do it, you can actually do it just by hand. Now, the thing you need to be careful of when you do that is that on a flooded battery, when you overcharge it, when you equalize charge it, you're going to be making hydrogen gas. So you need to be really careful that you don't have any sources of sparks. You want to make sure there's really no way that you can have a short circuit, because that hydrogen gas is explosive. So as long as you're venting it, if there's a breeze, maybe you've got a fan nearby, something like that, then it can be safe to equalize charge a battery. And a lot of modern battery chargers also have a feature that allows you to overcharge or equalize charge your battery Just make sure you're careful while you're doing it that you don't ignite the hydrogen gas because it can be explosive. So here today, we've seen the basics of what you need to make your own small 12-volt photovoltaic or solar electric system. We hope this helps, and thanks for watching. Come check out our other videos at knowpod.org, knowpod.org.